The so-called black hole information paradox, often discussed in textbooks, doesn't actually exist within the framework of the energy filament theory. According to traditional physics, once matter crosses the event horizon, any information is lost forever. But quantum mechanics tells us that information cannot be truly erased. These two statements create a direct conflict, and this paradox has puzzled physicists for years. However, in the energy filament theory, this paradox is non-existent right from the beginning. This is because black holes do not destroy information. Instead, they transform or rewrite it. To help clarify this idea, let's consider a vivid analogy. Think of a black hole as a paper shredder combined with a digital scanner. The paper might be shredded, but the text, handwriting, and arrangements get immediately scanned and stored as new data. The paper is destroyed, but the shadow of the information, its essence, remains preserved. Similarly, when matter falls into a black hole, it undergoes a transformation, but the information itself is not lost. Here's how the process works in 3 distinct steps. Step 1. The first stage is the deformatting of the matter in the crushing zone. As the material approaches the event horizon, the particles become incapable of maintaining their stable form due to the intense changes in the gravitational tension and the extremely slow passage of time. It may look like the matter is being crushed, but in reality, it breaks down into tiny, fragmented energy filaments. These filaments do not erase the information but simply scatter and fragment it into smaller pieces. Step 2. After this, the core of the black hole, often referred to as the boiling core, begins the process of rewriting the fragmented information. The energy filaments constantly twist, intertwine, and reconnect as they travel through the boiling core, which functions like a dynamic energy engine. In this stage, the original structure of the information is written into the tension patterns of the filaments, forming a new patterned form of information. This means the information is preserved, albeit in a new, restructured form. Step 3. Finally, the outer critical boundary of the black hole slowly releases this newly encoded information. This boundary, also known as the event horizon, is not a fixed line but rather a dynamic layer that constantly opens and closes tiny pores. These pores intermittently release small tension disturbances into the surrounding space, akin to fragments of the translated information being gently etched or inscribed into the fabric of the universe. In this way, the encoded information leaks out, gradually escaping the black hole. According to the energy filament theory, information never truly disappears. It simply transitions through various stages from particle language to filament language and finally to tension language, before being slowly released through the black hole's outer boundary. Since the information is never completely wiped out, the so-called paradox is effectively resolved. In fact, black holes are not information sinks or erasers. They are the universe's most extreme and complex re-encoders of information. In our next episode, we'll discuss, why does time behave so differently near a black hole? Tap follow, share it on New Physics, Clear Universe.